Hello friends, welcome back. Today we're on about inheritance. So I'm just going to open that by going open inheritance, about inheritance. You'll see that pops it up in Atom, and I'm just going to close all these older folders. So here we have inheritance. Cool. I can see if I run the rake task from our last video, I've got line 27 is failing, and so that is down here. And here we have a blank, which is, it says fill me in. This is supposed to equal true. So yeah, let's just have a look at this. So here we've got a class where we're setting up a dog. So attr reader, meaning that we can set the name. On initialize, we can set the name. It looks like we have to set the name. And then we have an attr reader, which means that if we, on initialization, we set the @name instance variable on the dog class equal to the thing that's been passed in. Let's just play with that real quick. So I'm going to take the dog class and pipe it into our Ruby IRB. And so now we have a class for dog. So if we were to say, say we had a dog named Rex, we can make it equal to a dog.new. And here we're actually going to get an error, right? Wrong number of arguments. Given 0, expected 1. Why is that? Well, on initialization, we need to pass in a name. So let's go dog.new, and we can set the name is equal to Rex. Cool. So now if we go Rex, you'll see it's not an error. We actually have a new dog instantiated in here, and it has name as an instance variable. And if we went to rex.bark, you'll see he'll go wolf. So that means you can get you've created a new instance of Rex, and then you can make him do things. So cool. But so right now, if we go dog.ancestors, you'll see we've got, this is just kind of goes up the chain, right? There's dog is an object is an object on the kernel, and kernel is an object on the basic object. So what they're saying here is we want Chihuahua to have their ancestors include the dog. Well, if we were to go just a Chihuahua right now, you're going to see it's an uninitialized constant. Okay, so what does that mean? We need to create a class of Chihuahua, but we want it to be a subclass of dog. And so that we've already created dog, so now what we can do is just do that. So I'm going to say copy this, and we'll just pipe this guy into here. So now if we go Chihuahua, but we go .ancestors, you'll see that we have Chihuahua, dog, object, kernel, basic object. So this is really important. Remember, the dog just had this bit, and now Chihuahua is a descendant of those. I think you can go dog.descendant. Okay. There's other ways to do that. I can't remember what it is now. But anyways, now what we can do is if we go chihuahua.ancestors.include, so chihuahua.ancestor, that gives us back an array, right? And so if what we're saying, does it include dog? Well, it does because it's there. So that will pass. So this will be true. Now, obviously, the answer was right here the whole time, but the only reason I'm walking through this stuff is just because I like to think kind of critically about it. This is the kind of essence of koans. Okay, so now, test all classes ultimately inherit from the object. So chihuahua.ancestors.include object. Well, if we look up here, chihuahua ancestors, yeah, there's an object in here. So this is also going to be true. If we go Chico is equal to, so we're test that subclasses inherit behavior from the parent class. So Chico is an instance of a Chihuahua. And if we go Chico.name, well, why is this interesting? Well, if you see that Chihuahua class is set here, but it does not have a name initialized on it. It doesn't have a name on it, but it is initialized up here. So what we're showing is that the Chihuahua, because it is a descendant of dog, it actually has these values here. So Chico.name is equal to Chico. Now, this seems like a fairly straightforward thing. You set it with a new name, and you see that they didn't have to do it. Oh, remember up here I did something funny. I did Rex is equal to dog.new with a name of Rex. Well, you don't actually have to do that. It could be Fido is equal to dog.new, and then just pass in Fido. And then you'll see it worked exactly the same way. So because the first parameter is a string and because we initialized it up here, we were able to set the instance variable of name to it. Cool. So let's keep going down here. We have test subclasses, add new behavior. So chico.chihuahua new. So we create a new dog, and then we assert equal chico.wag. So wag has it returns happy. We're just going to return a symbol. So if we go chico.wag, well, it's going to return the symbol of happy. Assert raise, dog.new Fido.wag. Okay, cool. So what's this saying? So Chihuahua, if we go, let's just pipe this in here, chico.new. If we go chico.wag, it returns this guy, right? But what happens, like Rex is just a dog, right? Yeah, Rex is a dog. So the dog doesn't have these methods on there. So I think rex.methods. Can you do that? Yeah, and this will show you all the methods that are there. And so Rex has a name and a bark method, but he does not have wag and bark. And if we go chico.methods, we're going to see wag and bark on here. So that's because the Chihuahua it has all the attributes of here, but the dog doesn't have the specific attributes of the things that a Chihuahua does. And so what happens if you go so we've got Rex, which is our dog, and we go what if we call something on here like wag? No method error, right? Because it doesn't exist on the methods for the dog isn't the methods for the Chihuahua are not specific to the dog. So we want to raise here, we're going to say no method error. So we're testing to see that this error comes up. Cool. So let's keep moving on. So here we've got Chico is equal to chihuahua.new Chico. And so we say, what happens when Chico barks? Well, because Chico is a Chihuahua, their bark is going to say yip because they're small dogs, right? But what happens if you go dog.bark? So Chico.bark is going to be yip, right? Because this method takes precedent over the dog method, because that's how it works, because of inheritance, right? So you'll see it's basically overwritten for the Chico, but for Rex, he's just going to have a normal dog bark of like a big woof, right? Cool. So Chico does yip, and Fido goes woof. Cool. And now we set a new one, bulldog. And so, wow, super plus. Test subclasses can invoke parent behavior via super plus bark growl. Oh, okay, got it. So the bark method, super is gonna take whatever is happening up above. So it's going to check woof, and then it's going to add. So this is going to return the string for bark on the parent class. So the dog. It's going to receive woof, and then so technically that's going to come out to right, woof, and then it's going to be plus growl, and we know that this returns us a single string. That's just string interpolation in Ruby. So super makes it so you just call the parent class. So Ralph is equal to a bulldog. Well, first off, we should instantiate this, and if we do it like that, now we have our bulldog class, right? And we could be like, what's a bulldog name? Ralph. We've got Ralph is equal to a new bulldog. Ralph, bulldog.new. And we're going to call him Ralph, right? Cool. So Ralph dot bark is going to be a woof growl, because it takes the super class, the result for a bark from the dog class, and then it adds a growl to it. So we want to assert equal. This is going to be woof growl. Cool. We save that. Similar thing down here. Great Dane. Diff growl. Okay. Bark. Super.bark. Okay, so super just means it's calling the parent class growl. I think that this one's going to be the same. So if we did a Great Dane, George the Great Dane. Oops, I want to put that up here. And then we say George is equal to Great Dane.new, and so we're setting it up for a new Great Dane, and we go George.growl. No superclass method for growl. Okay, so what are they saying here? Well, this is actually going to give us the method, so we can say this is also a no method error. And I think that's going to complete this technically, but what does this mean? A no method error. Okay, George is equal to a new Great Dane. It's a dog, but you see the only the growl method, super.bark. Okay, so what's happening here is that it's calling super for bark. It should be woof. I don't understand why that's not working. Assert raise no method error. George.growl. George.growl. It's a no method error. Why is that? George is a new dog. And he has George.growl is a method. Super.bark. So here it's saying super, so it's going outside of the Great Dane class, and it's going to the dog class. And it's saying bark. So dog.bark. Woof. Why is that a no method error? Okay, I don't really know the answer to that. I accidentally threw that in there. So let's just run the rake task and see what happens. Okay, it looks like we're on to about modules, so we're out of inheritance. And so yeah, this is actually kind of perplexing to me. Why George.growl, assert raise? So if George can't growl. George is a new instance of a Great Dane, and a Great Dane is a subclass of dog. So if you go George.growl, it's going to say super.bark. Oh, it's because, wow, this is pretty wild. It's because it's, yeah, don't know. That's how it's kind of interesting. This is something I'm not really understanding. If you think you understand why this one doesn't work and you could explain it fluidly, that'd be great. But we are passing all the tests, so I'm going to keep moving on to about modules in the next one. Hope you guys enjoyed this. We'll see you in the next video.